Yeah, how's it going? The language is getting a little too big for my liking. 13,000 lines of code. That is insane. That is insane. But we have more features. We have more features. We can define structs now, just like this. So you define it, you give it a field of type, and then you give it a field of type with a default of 0, and then you can give it methods, right? So they work from metatables, which I'm going to explain a little bit later. But yeah, and then it gives you back self.name, right? If you get name, that's kind of useless, but yeah, that's how it is. And then you define it like this. Now the reason this function exists is because for now they're just records. Because I couldn't be bothered with making them have good mutability, and I think that mutability is good. Mutability is good when it's explicit. So we define the u of user as let. So we have const and then we have let. Difference between const here and const in other languages is that you cannot shadow variables. Uh, because that makes no sense to me, right? If it's constant, that means it's constant. You can't make it anything else. If you shadow it, it's weird. It's weird. Just make it a let in that case. But yeah, and then you can spam methods on it, and then that gives you back the thing. So with age next, return self with a field set to someone else, and that's how it is. That's how it is. So how this works is this doesn't actually implement that much at runtime level, as in it doesn't implement anything at runtime level. The VM is only slightly modified. So let me find it. Yeah. Wait, no, it's not modified. I just had some debug code in there. Um, but yeah, this works at the level of we have tuples, and they can have stuff like this. They can have any amount of items, but they're immutable, right? You can make them dynamically at runtime from tables now, but yeah, they're just immutable. You can't do anything to them. And the reason I use tuples is because they're the most efficient data structure. If you look at them, VM tuple.zig, they have only 3 slots pointed to an allocator, some data, which is an array, right? It's an array, it's not a dynamic array. And that means we can technically store it on the stack a little bit later on, but I didn't get around to that quite yet. So that's just how it is. Then any type can have a metatable. And a metatable is a table with methods. So for example, this is a table, and then you can have, let's say, call equals a fan of self call, I guess. I don't know. Yeah, and you can assign that metatable through set meta table on any data. So a data is yeah, it's just data. So okay, let's say we set it on okay, and then we can call it, right? So const a equals this. Let me do this self 0 plus. No, you can't add two atoms actually. If self 0 equal equals okay, then error, and then we can call that negate, right? Else okay. All right, and then we want to do a negate just like this, and then we can remove. No, we actually don't have to. So print a negate just like this, and let me, if self okay, then error unexpected token one. What are you talking about? What are you talking about? Yeah, just like this, just like this. Why is it not work though? Why is it not work though? If self 0 equals okay, then error. That's weird. That's weird. That is some like passive stuff, but just how it is. And then we can do it like this. So you can set any function on it. But it doesn't just apply to functions. So if you go into root.zig to refresh my memory and tell you no, a different root.zig, just normal root.zig, we have those core items. We have those core items. So you can set a underscore index equals underscore index equals a fan of self, and then n, right? And you return n by 5, for example. You don't actually have to return it. You can, obviously, by the way, if you haven't seen a normal function, they just look like this, right? They do exist. They do exist. Just that I don't use them, right? Because there's a lot of like one-liners, and you want to save your space on one-liners. You want to make them more readable. You want to have less noise on them. So that's how it is. A, and then you index as no index 7th, and that's gonna give us 35, which is n by 5 exactly. And then you want to do a new index equals the fan self, and then n you do n by 7, I guess. I don't know. A7 equals as, right? And low O. Yeah, it's because of this. So yeah. What's going on? What's going on? New index. What am I using new index? Hello? VM new index. Average meta new index, constant meta table, main six. Yeah, so it's here. New index. Oh, I'm just not using it. Since when? Did I nuke it somehow on accident? That is unfortunate. But yeah, I used to have that. That used to work actually. So yeah, you can and then you can override stuff like self and then other, and then you do other by 7, a plus 7. Right. So this is gonna have some pattern matching later on, probably if I'm good, if I get good at the thing. But yeah, not now, not now. That is unfortunate. That is just not what's gonna happen. So yeah, what else do I have? What else do I want to tell you? Oh yeah, so we have tuples. We have tuples as backend types. Yeah, exactly, exactly. So let me actually zoom out a little bit. So compile struct, right? And then you get a struct descriptor. And then the struct descriptor is going to be passed from this. This is very similar to tables. Except all of this, every single thing is a binding that's separated by nothing, right? So you don't even have to have commas because a new binding has to wait, is it actually did I make it a pass let me pass structs, right? Does it no. I made it good. I made it good, right? Because I have some things in here that terminates other statement-ish thing. So they're all expressions, right? This is an expression. You can just do it like this. And the word age right here terminates it, right? Because there's no equal sign. And there was an equal sign, it would say like, yo, string equals age colon, and then it would error out on colon. Am I wrong? Let's go. Let's go. Yeah, so that's how it works. That's how it works. It's just a bunch of bindings, normal bindings that you have in your language. Um, so and that builds a table out of that. So if I go into compile.zig, so we have those things that I passed the instruct field. Instruct field is going to be a little bit different from a bind, but yeah, it's going to have like it's pretty straightforward. So and then you make a new table, which is it's unfortunate. What else is unfortunate is that I have hidden globals, which you don't wanna have that, but I do, because the compiler actually does things to the VM, so it is not completely separate, right? It needs to intern some atoms, right? So this is an atom and it's interned, so that's how it is. That's how it is. And then you go on and then you build a table, right? And then you can compile the struct, which returns a function, right? It returns a function which is actually gonna call this function as struct underscore new, right? And I think I've shown you that already. No, right? So struct underscore new gets a struct descriptor as a table with all of its fields and defaults and values, and all that, and then it's builds something out of that. So yeah, that's how it works. That's how it works, and then it gives you back the tuple, and then the tuple has a meta table, and the meta table has a set index, and then it has all of the other method sets. So if say for example I actually didn't test that at all. So this is implicit behavior already, but const underscore add equals fen self and then other, right? And then you return other plus 42, right? And then you do print u plus 123. Yeah, yeah, it does work. It is implicit actually, which is amazing, right? So you have all of that like immediately. This is a language that I keep on discovering, which is insane, right? So uh, rules come out of rules, and they make sense somehow, and they make sense. It's just important to make sure that the rules only make sense. So that's how it is. That's how it is. Yeah, you can set it. You can set our method. So we have actual. So the thing I really liked in Rust is that you have your debug and then your display trait. So if I go into, where is it, bro? Where is it? Right here. Yeah, so you do have underscore debug and underscore toString. So underscore debug is going to be in a fan of self, and then it's going to return debugs true, right? And then you can print it, right? So you do that by doing println, or so println is a macro, and then you can give it this format specifier, which is of debug. So if I go into natives .zig and then fmt fnfmt, let me do this. Yeah, so this is debug. This is digit, and I've always done d for debug, which confused me a lot, but I still left it like that. I still left it like that because that's what people are used to. Const underscore debug. Oh yeah, it's because I didn't put a comma there. And I didn't put a comma there. And I didn't. No way. I shouldn't be though. I shouldn't be doing a comment there. No, should I? No. Wait. Let me. What am I doing? What am I doing? No, no. This is all falling apart. Uh. Oh yeah. Yeah. No, it's not. It's not. I just missed a equal sign. Yeah, that makes sense. I'm so not used to coding without treesorter or LSP that's just how it is. So, why is it not applying? Why is it not being applied? That is unfortunate. That is absolutely insane to string. Oh yeah, yeah. Wait. So why is it doing that? Huh? Append data results dot debug, right? And then debug. Oh, this. Oh, I have different distance. Hello. All right. That is insane. I didn't even know I had that. Why do I have this? Should probably not be doing this. Do I use it anywhere? No, I have one test for it. I'm just gonna leave it for that one test, and I'm gonna remove that a little bit later. Right? Because it should just be toString. It shouldn't be display or something. Maybe I should actually have three of them. Right? Because if you want to do JSON, you want to have the compact JSON for toString, and then you want to have the pretty printed one for. Well, actually, that's debug. That's just debug. So I don't know. But yeah, you have toString methods. So you have most of your functionality. The unfortunate part is that they're actually just records. So tuples are immutable, and with that comes the fact that you have to do this, which I think I've talked about already. I have really bad memory. So thank you for watching. Thank you for watching. You have to promise me that when this is public, you will help me out. Right? You have to help me out because I cannot manage doing all this myself, like at good quality.